For the first step, we must convert all given that are polar to rectangular and vice versa. For polar to rectangular, our formula would be r CJS theta is equal to r cosine theta plus jr sine theta. For rectangular to polar, our formula would be r is equal to the square root of a squared plus b squared. And to get the angle, our formula would be theta or angle is equal to arc tan b over a. Our first given, RT, which is 7 plus J24 ohms, will be substituted to our formula for rectangular to polar, which would give us the answer 25 CJS 73.74 degree ohms. Our inductance, which is 50 CJS negative 36.87 degree ohms, will be substituted to the formula of polar to rectangular, which would give us the answer 40 minus J30 ohms. And lastly, for the capacitance, which is negative 12 plus J5 ohms, it will be substituted to the formula of rectangular to polar, which would give us the answer 13 CJS negative 22.62 degree ohms.
So to get the total impedance of the circuit, we'll use the formula Z equals the square root of R plus the difference between inductive and capacitive reactance squared. Now let's substitute the given values. Remember that for addition and subtraction, we need to solve it in rectangular form. So first, the resistance is given in rectangular form, which is 7 plus J24 ohms, but we're going to convert it into polar for easier solving. So when you convert it to polar form, it is 25 CJS 73.74 degrees. Next, the inductive reactance is also given in polar form, which is 50 CJS negative 36.87 degrees. So converting it into rectangular form will give us 40 minus J30 ohms. The capacitive reactance is already in rectangular form, which is negative 12 plus J5 ohms. So now let's solve it. 25 CJS 73.74 degrees squared is 625 CJS 147.48 degrees. Then we subtract the capacitive reactance from the inductive reactance, which is 40 minus J30 minus negative 12 plus J5, which gives us 52 minus J35. So here, Z equals the square root of 625 CJS 147.48 degrees plus 52 minus J35 squared.
After getting 625 CJS 147.48 degrees, convert 52 minus J35 to polar form. Then it will become 62.68 CJS negative 33.94 degrees. Then copy 625 CJS 147.48 degrees. Then square 62.68 CJS negative 33.94 degrees. Then it will become 3,928.78 CJS 67.88 degrees. After that, convert both to rectangular form. Then it will become negative 527 plus J336 plus 1,479.37 minus J3,639.61.
Before solving for the current, we must first solve for the total impedance in polar form. To do that, we must first convert 952 minus J3304 into polar form. First, we find the modulus by using the Pythagorean theorem, where A is equal to 952 and B is equal to negative 3304. Once we get the modulus, the next step is to find the argument or the angle. To do that, we can use the arctangent function B over A, using the same values from earlier. After getting both the modulus and the angle, we can now rewrite it as 3,438 CJS with an angle of negative 73.92 degrees. Now we take the square root of this value, but to make it easier, we can rewrite it as 3,438 CJS negative 73.92 degrees raised to 1/2. This allows us to use the formula r raised to 1/2 CJS theta times 1/2. We get the value Z is equal to 58.63 CJS negative 36.96 degrees ohms.
To determine the current, we'll use the formula I is equal to total voltage divided by the impedance. Now let's substitute the values. The total voltage is already given as 200 CJS 180 degrees volts, and the impedance, which was solved earlier, is 56.64 CJS negative 36.96 degrees ohms. So when we divide 200 CJS 180 degrees volts by 58.64 CJS negative 36.96 degrees ohms, we get 3.41 CJS 216.96 amperes. Therefore, our current is 3.41 CJS 216.96 amperes.